Welcome. This is Small Head Big Problems. I'm a small head and I've got big problems. We're continuing with the TMUA. Yeah, trying to do 3 questions as fast as possible with no prep. Let's go. Cool. I'm continuing the 2016 paper. It will be question 16, 17, and 18. All right. So, question 16. Given the simultaneous equations, log 2 plus log 1 y minus 1 equals 2 log x, and log y plus 3 minus x equals 0, the values of y are there. All right, so there's 2 variables, y and x, and they want the values of y that satisfy the simultaneous equation. Okay, try this question yourself. Let's go. I mean, straight away, I'm thinking log rules. I'm thinking, you know, exponentiating both sides um, hmm, to simplify. So, this first left-hand side is going to give us log 10, 2 times y minus 1. All right. If we exponentiate both equations, we're going to get 2 times y minus 1 equals, oh yeah, and this side, log of x squared. All right. So you're going to get 2 times y minus 1 equals x squared, and down there, just y plus 3 minus 3x equals 10 to the 0, which is 1. Easy. Just solve for y in this one. Actually, yeah, yeah, yeah. Solve for y in this one, and then plug it in here. That will actually we'll solve for x there, and then plug in the values of x into y. That's easy enough. We could also just substitute for x, or yeah, actually maybe why don't we do that? Like if I just isolate a 3x here, get y plus 2, right? 3x equals y plus 2, okay. And then instead of like dividing by 3 and putting it in, well, okay, actually let's do that. It's 2 over 3, put it into the first equation, 2 times y minus 1 equals y plus 2 over 3, all squared, times everything out, times by 9. Expand this. Expand everything, take it to one side. It's 22. Okay. Um, yes, looks good. Yeah. So 22, that's 11 times 2. Nope. Uh, oh, yeah, but actually I see some roots, so probably just quadratic formula. Y equals 14 plus or minus 14 squared minus 4 times 22 over 2. So, I mean, already I can see it's probably C, right? I mean, because it's 7 plus or minus something something. And I'm going to get, right, 7 plus or minus. Little big tip, right, when um, simplifying these. In fact, they should change the quadratic formula, to be honest. But, you can always take out, like, square factors, right? So you're going to be able to take out, like, 2 squared out of this one, and also 2 squared out of this one, right? 2 squared is 4. So if we do that, then we'll end up with, 2 times 7 squared minus 22 there over 2. So the 2's cancel. 7 squared is 49 minus 22 is 27. And 27 is 3 squared, So it's a factor of 9 you can take out, basically. So yeah, it'd be 7 plus or minus 3 root 3. So indeed, it's C. Let me check the answer for you. Yeah, so correct answer. I see, yeah, something that sort of is really important whenever solving these kinds of equations is like, do they make sense? Because, um, you know, not the logarithms only define on positive numbers. Turns out they do make sense, but that's not really required for the question. Okay, easy peasy lemon squeezy. Moving on. 17. It is given that y equals 1 plus 2 cosine x times cosine of 2x for x between 0 and pi. The complete set of values of x for which y is negative is... Okay. I mean, I'm thinking just... Oh, sorry. I'm thinking just like sort of plotting each function between 0 and pi, like this one and this one, because they'll be negative exactly when they have different signs, and it'll be pretty easy to tell. So, so as we know, cosine x from in the interval. Okay, so cosine x looks like this, right? Etc. Um, so that's yeah, that's like pi, right? 0 to pi, right? Half period. So if I do 1 plus 2 cosine x, which is this first part, I just need to scale that by 2 and add 1, right? So it's gonna start at 3 and go down to -1 somewhere. Oh yeah, and just something like that, right? -1, 3. And when is it gonna be 0, right? That's probably important. Well, let's worry about that later. And then cosine 2x is gonna be, same as cosine x, but just compressed by a factor of 2, right? It will run two times fast, so it will go through a whole period in 1, and so it will look like this. Okay, so when do they have different signs? Well, yeah, so either like in this interval, right? Where one's positive and the other is negative, and that is between, sorry, that's very, when this is pi, so this is obviously pi by 4 and 3 pi by 4. All right, so the first relative interval is pi by 4, 3 pi by 4. I'm not sure why I drew it so small. I'm so sorry. And then, yeah, we need to figure out basically where that crosses, which, yeah. What seems to work here? What seems to be working? This is not very good. A complete set of values of x for which y is negative. Doesn't really look good right now. Um, hmm. Okay, yeah, I need to figure out where this crosses the x-axis. So when is 1 plus 2 cosine x equal to 0? Yeah, I think I made it cross. Yeah, my picture isn't great. So cos x equals minus half. So x equals, gotta know your exact trig values, right? Minus half. That will be when x is nowhere. Wait, I'm confused. I am confused because from 0 to pi, that's always positive. Okay, what? So I made a horrible mistake. No, I don't understand. It varies between 1 and -1. If you scale it between 2 and -2, and it's going to be negative at some point. Wait, what the hell? Someone's calling me. What a horrible moment. Why? This is so weird. I don't understand what's going on. I do not understand. I do not understand. Mm, wow, I'm a stupid ass. This is... Okay! So that's 2 pi over 3, which actually comes before, um, it actually comes before 3 pi over 4. So, oh, why is it a different? So more like this. So actually, uh, right. So actually, there's one. One. There's one interval which is this one, which is between pi over 4 and that 2 pi over 3. And then another interval which starts here at 3 pi over 4 all the way up to pi. Yeah, so it's D. Let me have a look. The answer is D. Cool. Right. That was a bit awkward. Um, all right. Let's go. Not doing too badly. The function 1 minus x over cube root of x squared is defined for all x not equal to 0. I agree with that. The complete set of values of x for which the function is decreasing is... Okay, I mean, like, so surely just take the derivative and see when that's negative, right? Okay. Okay, so first of all, f of x is 1 minus x over x to the 2 over 3. My family is calling me for Hanukkah. What a bad moment. Um, which I do not, I mean could use quotient rule, but I'd rather break that up. X to the minus 2 over 3. Although might be a bit awkward afterwards to find out when it's less than 0. We'll see. X to the minus 2 over 3 minus x to the 1 over 3. Sorry, that's still f of x, not f prime of x. Then you differentiate. You know, this whole time I'm thinking like, um, yeah, but hmm, yeah, this is defined for all x non-zero. Um, so let's figure out when this is equal to 0, I guess. I think, yeah. Um, because I could set this less than 0, but the problem is then to manipulate it, it's like I have to like multiply by something. I don't know if it's positive or negative. Let's see. Well, actually, no, that's fine, because I could multiply by x to the 2 over 3, which is the cube root of x squared. And that's always positive, right? So if I multiply by x to the 2 over 3, I get minus 2 over 3 minus, minus 2 over 3x minus a third is less than 0. Yeah, seems to be okay. So, um, yeah, instead of dividing by negative numbers, I like to kind of take this to the other side. So 2 over 3x greater than minus a third, and then times by 3 divided by 2, so x greater than minus 2. Um, that's not good. I just differentiated completely wrong. This is minus 5 over 3. I just kind of integrated instead of differentiated. Ay, ay, ay. It's too late to record a video, is it? In which case, I mean, I can still times by x to the 2 over 3, but here I would get minus 1. Um, so yeah, basically 1 over x here, which, yeah, I mean, it's awkward, but okay, I get 1 over x there, and then if I can take the reciprocal, but taking reciprocal is a decreasing function, so you'd have to flip the sign of the inequality. Strictly less than minus 1 over 2. That doesn't work either. Why did I do this at this time? Um, okay, yeah. So sorry, because that's minus 1/2. So that's minus 2. Okay. So just x less or equal to minus 2. I'm... What the hell, man? Um, I just completely messed up at the beginning. 4x greater than 0. What did I miss? I've missed... I feel like me doing this inequality is just weird. What the hell? Like, what? I do not get it, man. I really don't. This cube root of x squared minus x to the 2 over 3. What can I say? Unless it's just not. Maybe that's only if x is positive, but that works. To record a little post-mortem. Um, yeah, why did I get all confused and get this question wrong, and what should you do and avoid? So at one point during my inequality, I think there wasn't a mistake until the very last line. I said if 1 over x is greater than minus 1 over 2, greater than or equal, whatever, then I can take reciprocals on both sides and get x less or equal to minus 2. And why do I think that? Because I said reciprocal is a decreasing function, right? So like 1 over x is a decreasing function. So, oh, my doggy. Um, so if yeah, if you sort of start with one thing being greater than the other, you apply that function, it flips the direction, right? It flips the order of them. If 1 over x was a decreasing function, that would be true. But it's not a decreasing function. Like, it kind of looks like it's always decreasing, right? But it's not, because, for example, here you have -1, and here you have 1, and yeah, like the function evaluated at 1 is greater than the function evaluated at -1, right? So it's decreasing on each, so that's false, basically, because it's decreasing on each interval x, x greater than 0 and x less than 0 separately, yeah, but not overall, not on the whole real line. And so that confusion comes from the fact that there's basically a discontinuity, right, at 0. There's a jump, there's an asymptote, so it just jumps from like basically -infinity to +infinity all of a sudden. So yeah, that's why that step was wrong and why I missed x greater than 0, right? So in reality, I mean, I could have done okay with that because I could have just like plotted the function and said, okay, right, this is like y equals -1/2, right? So here's -2. So either I'm less or equal to -2, right? Either I'm in this interval or I'm in this whole interval. So yeah, that which is the correct answer. So there you go. So it's this kind of like solving inequalities is awkward. So it's better to like I think it's great to like factorize the thing into factors that you understand well, that you understand the sign of, and then make a table of signs, right? So I think that the derivative was something like there was some factor, I think -1/3 x to the 2 -2/3, if I'm not mistaken, times x plus 2, something like that, right? And then you can make a table of signs for each sort of x to the -2/3 and x plus 2, and careful, -1/3 as well. So that's obviously always negative. X plus 2 is sorry, negative here and positive here, and x to the -2/3. That's actually always positive, right? Yeah, because it's like a cube root squared, and then take the reciprocal. Yeah, so that's always positive. Wait, what am I doing? Is this also wrong? Sorry, so it was x to the -5/3. Right, x to the -5/3. So actually, that's yeah, that changes sign between yeah, sort of it's yeah, negative when x is negative and it's positive when x is positive, because it's like x to an odd power to the power 5. So basically, you've got like a break here. So overall, you have like negative. So f prime x is the product of these. So it's sort of negative, and then here positive, and then here it's back to negative, right? So yeah, again, the answer is A, x less or equal to -2 and x greater than 0. Okay. And the other thing I want to warn you about is you could also kind of go like, okay, f prime of x equals, was it like a -1/3 x to the -5/3 -2/3 x to the -2/3, right? Equals, you might basically find where this is equal to 0, so where there might be a sign change, right? And so is it positive, negative, right? Because it's like, okay, if you kind of find where it's 0, then check either side of that 0, whether it's positive, negative, stuff like that. You can do it, and you'll find that like basically if you solve that equation, you can like multiply by like x to the to the 2/3, so or divide by this, so you'll get like x to the -1 minus 2/3 equals 0. Eventually, you get to like x equals 2, right? That is the only 0. But you have to be really careful because if you just kind of go right, basically there's -2 and then like -infinity and +infinity, and then you check at like -3, for example, and you find that it's positive, and you check at -1, you find that it's sorry, you find at -3 it's negative, and you find that it's positive at -1, and then you conclude, okay, so it's only when x is less than -2, right? Because how could there be a sign change, later on here when there's no 0? Well, there can be, because there is a singularity at 0, right? The function is undefined there. There's an asymptote. There's a break, right, in the function. It's not a continuous function, right? Just like 1 over x is not a continuous function, and that's where the whole confusion came. So yeah, so in fact it does have a sign change once you just pass that singularity. So basically, like, you have to be really, really careful when dealing with discontinuous functions. We're really used to working with functions that are continuous over a continuous interval with no breaks, but this is where our intuition kind of fails sometimes. So you have to be really careful. So yeah, I think, my general piece of advice at the end of the day, it's usually much safer to just factorize the expression that you want to basically decide what is its sign and decide each part what sign it is and when, and do a little table of signs like that. That's the safest way to go about it. Yeah. And this will be well, this will be negative times another negative. So negative times negative is negative. So it's negative in this interval. From -2 to 0, the sign of this doesn't change, the sign of that doesn't change, but the sign of this changes back to positive, so positive here. And then from 0 to plus infinity, this is positive, and that's negative, so it's back to negative. So answer is A. Okay, thank you very much. Hope you enjoyed, hope it was useful. Please like and subscribe if you found it useful, and if you want private tutoring, do drop me a message. Thank you so much.